Hi there! With this lecture, we start a new section in which we will discuss another built-in data structure of Python, which is a dictionary. So in the first lecture, let's identify what's a dictionary. A dictionary is a collection which is unordered, changeable, and indexed. As the name implies, the dictionary is modeled on its real counterpart, where you have a word and associated meaning for this word. In programming, we use dictionaries to associate a key with its value. So any value can be identified as long as we know the key. If you look inside the real dictionary, we will find words, and each word has a combining explanation and meaning. In this case, we have a miller here, who is a person who owns or works in a core mill. So this is a word from real world dictionary. So there is a similar concept in Python in which we can express the preceding dictionary entry like this, where a key is a word from a real dictionary and the value is a combining explanation. And you can create a dictionary and you can put it more than one of these key value pairs. So in our case, we have two key value pairs over here. The first one is miller, then we have explanation, and the second one is programmer, then we have explanation. Now in previous sections, we have learned about arrays and lists, which are very similar to each other with minor differences. So we know that arrays and lists are another collection type where the sequence of data matters most. So for example, if we have an array or list like this, to access first element, we need to use index 0. If we want to access the second element, we need to put index 1 over here to access the element over here. Now in the dictionary, it works slightly different. The data is organized using key and value pairs. Here, we will retrieve the data using the key. For example, if we want to retrieve a data for this value over here, we need to write dictionary name, then the key value over here, then it will return the value of this key over here. So to understand the difference between arrays and dictionaries, let's look at real life example. Now let's say you get a job at the local cinema in their cloakroom. In order to organize your cloakroom so that it is as efficient as possible, you have devised a way of taking customer codes and hanging them on coat hangers sequentially. As new customers come in, you hang the codes on the next available coat hanger and give them the ticket that identifies the number of coat hanger. So as more and more customers come in, you hang the codes on sequentially and give them the ticket numbers. Now once the film is over, the customer come back looking for their codes. As long as they give you the ticket number, you will be able to identify the hang number and give them their coat jacket back. So this is equivalent of array where ticket number shows the indexes and the code shows the values. So if the ticket number is 0, you will give the code from here. If the ticket number is 1, you will give this code over here. Now the problem arises when a customer are getting a little bit drunk and they have lost their ticket. Now without knowing the number, there are a whole bunch of code checks that look very similar to each other. You won't be able to easily identify whose code belongs to whom. So to avoid this situation, here's a different way of organizing the cloakroom. In this case, you are writing the customer's name on the ticket and you are hanging the code in coat hanger, putting their name on it like this. So with this way, it's easily identify whose code is this. So as more customers arrive, you are taking their name and putting on the coat hanger and it's continuing like this. So even if your customers get a little bit tipsy, hopefully they don't forget their name. And as long as they provide their name, you will be able to identify the code jackets that's associated with it. So this is equivalent of dictionary. In this case, the sequence does not matter. The name is the key and the value is code that associated with this key. So hopefully with this example, you have understood what makes a dictionary different from an array. So in a list or array, the index positions have to be integers. In a dictionary, the indexes can be any type. As you showed here, the index here is name, which is type of string. So this is all for this lecture. Hopefully you understand everything here. Now in the next lecture, let's see how can we create a dictionary in Python. Hi there. In the last lecture, we learned what a dictionary is, and in the definition of dictionary, it says that a dictionary is a collection which is unordered, changeable, and indexed. It means that the dictionary will not be in an order that we created, and we can change the elements of dictionary after declaring it, and its elements can be accessed using keys. So in this lecture, we will learn how to create a dictionary. One way of creating dictionary is to use dict function. By using dict function, we can create a dictionary like this. Let me switch to Python. So here I can use dict function to create a dictionary. As an example, I will create my dict function. If I print out our newly created dictionary, you will see that we created an empty dictionary here. This curly brace over here shows that this is an empty dictionary. Another way of creating an empty dictionary is we can use just these two curly braces over here. So let's create it. Second dictionary. I'll put like this. So if I print out this dictionary over here, you will see that this is also an empty dictionary. So if we want to create a dictionary with elements, we will use syntax like this. To make it more clear, let's use a real dictionary example, in which we will be the dictionary that maps words from English to Spanish. So the keys and the values are all strings. So here I will create a new dictionary, English to Spanish. Here I will put elements like this. Inside curly brackets, one in Spanish will be uno, and then I'll put comma and second pair. Second pair will be 2. 2 will be dos. Then 3. 3 will be tres. So here we create a sample dictionary which translates numbers from English to Spanish. So if I print out this dictionary, you see that our dictionary has 3 pairs. So this is one pair, this is another pair, and this is third pair. So by using these curly brackets, we can declare as many as pairs in our newly created dictionary. So it's possible that when we print out our dictionary over here, the order of elements will not be the same that we declare here. But in our case, we see that it's the same, but in many cases, it will not be the same. The order of elements will not be the same that we declared because dictionaries are an ordered collection. And this is not a problem because the elements of dictionary are not indexed with the integers. So as far as we know the key of the pairs, we can access the value of it here. So how can we access the value of this pair over here? So we can use something like this. If I put the dictionary name and inside bracket, we will put the name of key. So for example, if I want to access the first pair over here, we will put 1. If I run this, you see that it returns uno, which is the translation of 1 in Spanish. So if I want to access, for example, these pairs over here, we know that the key of this pair is 3. So if I put 3 over here, we will receive tres. So as you see, this is different than arrays. In array, we are putting the index to access an element in the array, but here we are putting key to access the value of that pair. So what will happen if we put a key that does not exist in the dictionary? So in this case, we will receive an exception. Let's try it. For example, if I put here 4, you see that we receive exception. This exception says that so we don't have any corresponding value in this dictionary. Now the time complexity for accessing an element in a dictionary is O1 time complexity. Because here we know the key of the pair and we directly access the value of pairs. So this takes O1 time complexity. So this is all for this lecture. Hopefully you understood how can we create a dictionary and how can we create an empty dictionary and how can we access elements of dictionary using their key values. Now in the next lecture, let's see how dictionaries are represented in memory. Hi there. In this lecture, we will look at how dictionaries are represented in memory. Dictionaries are indexed by keys and they can be seen as associative arrays. Python dictionaries are implemented using hash tables. It's an array whose indexes are obtained using a hash function on the keys. The goal of hash function is distribute the keys evenly in the array. A hash table is a way of doing key value lookups. You can store values in an array, then use a hash function to find the index of array cell that corresponds to your key value pair. A hash function maps a key to a hash value and then an index of the array. As you see in the picture, based on key, a hash function calculates the index, then key and pairs is located in an array in the memory. This increases the performance of dictionaries. So there are 3 main elements in hash tables: the keys, the array, and the hash function. A good hash function minimizes the number of collisions. So you might be interested, what is collision? So these cases over here are collisions, which means that different keys have the same hash value, and this results the same index. Python does not have this kind of hash function that can eliminate all collisions. Let's look at the dictionary that we created in our previous lecture and see how this is located in the memory. And let's see how the hash function will work for dictionary over here. So when we create a dictionary like this, hash function calculates the index of any value pair based on the key value, and after finding the index, it places it in memory. It will start from the first pair. First, we will calculate index for 1. So the hash function will take as an input key value over here. Our key is 1. And this is the hash function result from Python. And based on this, it calculates the index of this element. So after calculating the index, for example, in this case it's 3, it will store these pairs in this array at the index of 3. Then it will continue to the next pair. And next pair's index will be calculated based on key value over here, which is 2. So for 2, again hash function will take 2 as a parameter, then calculate this value, and based on this value, it will give us the index. So for this case, for these pairs over here, the index is 1. So the elements will come here. So these pairs are stored at the index of 1 of this array. Then it will continue to the next element. The next element is 3, and the hash function will take 3 as an input, then calculate the index based on the value from here. If you run hash function in Python for 3, you'll get this value over here. And based on this value, it's calculate the index. Now here you see that the index is 4. So these pairs are located at the index of 4 of this array. So there might be situations that when calculating any given element's index, it might be the index that we have already occupied. So what will happen in this case? In this case, for example, after some values, if we want to add 10 to this array, for example like this, and based on calculating hash value, we see that the index comes 1 again. So which means that if we want to add it here, it will come here and see that there's an element already occupied this location. So what will happen in this case? In this case, the collision happens, which means that the best hash function should avoid these cases over here. But in this case, it will work like this. We are adding this element at the end of this element as a linked list. So for now, you don't know what's linked list. It's another data structure which will be discussed in upcoming sections. But for now, you should know that if an element causes collision over here, it will be added at the end of this element here as a linked list. So that's how elements of dictionary are located in memory. And this is all for this lecture. And now hopefully you have an idea of how dictionary is located in the memory. Hi there. In this video, we will look at how can we update an existing pair in the dictionary and how we can add new pairs to the existing dictionary. As I mentioned before, dictionaries are mutable. We can add new items or change the value of existing item using assignment operator. If the key is already present, the value gets updated. Otherwise, a new value pair is added to the dictionary. Let's imagine that we have a dictionary like this. myDict equals, let's create something like this. Here I have a key name which will be Eddie, and another key which will be the age of Eddie is 26. So this is our dictionary. So if I want to update any given value over here, I need to access the key and using assignment operator change the value. In this case, we will do like this. myDict, I need to, for example, if I want to change the value of age, I just need to copy the age from here and put it here. And with assignment operator, I can put here, for example, 27. Now, if I print our dictionary, you will see that the value over here is changed. So let me print out this dictionary. Let's save this and run our code. You see that the value for age is changed. I can change the name value over here as well. To do so, I just need to access the name and change the name over here. So this is how the updating of an element works in dictionary. So the time complexity for this is O1 time complexity, because in this case, we are just accessing this straight away to the pair and changing the value. We don't do any looping or any searching of operation over here. And the space complexity also is O1, because here an extra memory is not required. Now let's see how addition is working in dictionary. Addition pairs to the dictionary is also done by using assignment operator. In this case, it's checking that if the key exists in the dictionary, it's updating the value. If it does not exist, it's adding new value. For example, in this case, if I want to add an address for this person over here, I just need to write something like this. Address. For example, I'll just put city name, London. If I run this and print out our function, you will see that new pair is created over here with the key address and the value is London. You can add as many as element you want to this dictionary. Now let's see what is the time and space complexity for this addition operation. The time complexity for adding a pair to the dictionary is O1 time complexity, because here we are just adding key and value. But the space complexity for adding pairs to the dictionary is amortized O1. In most cases it's O1. It changes to ON when underlying data structure needs to grow or shrink. As the latter only happens infrequently, people use the word amortized. For example, if we add pairs to the dictionary and the capacity of dictionary is reached, the space allocation is doubling. That's why the space complexity becomes O1. So that's why it's called amortized O1. Now, this is it for this lecture. In this lecture, we have learned how can we update an existing pairs in the dictionary and how can we add new pairs to the dictionary. Hopefully, everything is clear now. Let's continue to the next operation. Hi there. Now in the previous video, we have looked at how we can add a new element to the dictionary and how can we update existing pairs. Now here, we will learn how to traverse through a dictionary. We know that traversing means visiting all pairs of a dictionary one by one. There are many reasons for this, such as updating pairs one by one or printing out their values and so on. If you use a dictionary as a sequence in a for statement, it traverses the keys of dictionary. So here, I will create a new function which will traverse through this dictionary that we created in previous lecture. So let's create it. The function will be traverse dict, and this function will take as a parameter dictionary. Then we will create a loop which will loop through this dictionary. So for key in dict, in this case, it's visiting all keys inside the dictionary. Here we will put like this. We will print these pairs one by one. Print. First we will put key, and then inside dict, we will access the values by using key. So this is how we are traversing through a dictionary. So if we just run this function for this dictionary over here, we will see the result. So traverse dict, it will take as a parameter this dictionary over here, which is my dict. Then let's save it and run it. You see that it's visiting all elements one by one and printing out the pair. So the first element is the name. The first pair's key is the name and the value is Eddie. Then the key is age and the value is 26. And then the key is address and the value is London. So it's visiting all of them one by one and printing out the key and value pairs. So you might be interested, what is the time and space complexity for this operation over here? So let's look at time complexity first. We know that to find the time complexity of a given function, we need to look at all lines one by one. So here we have print statement. We know that the print statement takes O1 time complexity. And inside print statement, we have only key, and we are accessing the value of this key inside the dictionary. And we know that accessing any given value in a dictionary is O1 time complexity, which means that this code of line over here will take O1 time complexity. Then let's look at the next line of code. Here we have loop operation. We know that looping through any given collection is O(n) time complexity, because here we have to visit all elements one by one. So this part over here will take O(n) time complexity. So if you combine all of them, it will be O(n) time complexity. And the space complexity for this operation is O1, because here extra memory is not required. We are just visiting the elements, and we are not even storing any element in a temporary variable or something else. So that's why space complexity is O1. Now this is all for this lecture. Here we have learned how can we traverse through a given dictionary. Now in the next lecture, how can we find a value inside given dictionary. So see you there. Hi there. Now in the previous video, we have looked at how we can traverse through a given dictionary. Now here we will look at how to find an element in the dictionary. There are many algorithms for searching a given value in the dictionary, but here we will look at the simplest one, which is linear search. The logic behind linear search is based on traversing a dictionary. This means that we have to visit each and every element of dictionary and check if this is the value that we are looking for. So here I will create a new function which will search for a value inside the dictionary. So let's create a new function, search dictionary, and this will take two parameters. One parameter will be the dictionary itself, and the other parameter will be the value that we are looking for, value. So here, one more time, we will loop through this dictionary and find out that if this is the value we are looking for or not. So for key in dict, this is the parameter that comes from here. Inside this loop, we will write if condition. If this is the value that we are looking for, we are using key to access the value, is equals to value. Then we will return key and value pairs. Otherwise, we will return that the value does not exist. The value does not exist. So if we save this file and run this function for this dictionary over here, for example, let's search for value of 26. So as a first parameter will be this dictionary over here, and the second parameter will be value. So if I just print out the return from this function and run our code, you see that we have error because I haven't provided value over here. It should be 26. So if I run it, you see that this pair from here is printed out. So let me put, for example, 27 over here and save and run it. You'll see that it says that the value does not exist, which means that by traversing through a dictionary, we can check each values of pairs one by one and return key and value if it exists over here. Now let's see what's the time and space complexity for this operation over here. So one more time, we will start from here. This is just returning key and value, which means that this is O1 time complexity. Then we are continuing to the if condition. If condition over here also takes O1 time complexity, because we know that accessing any pair value through key is O1 time complexity, so if condition over here is O1 time complexity. But traversing through dictionary is ON time complexity, because here we have to visit each element of dictionary, that's why this is ON time complexity. And return over here also is O1 time complexity, so which means that if we combine everything together, we will get ON time complexity, because when we're combining the complexities, we are eliminating the non-dominant terms, so we know that O1 is non-dominant term in this case, that's why the time complexity will be ON. And the space complexity is O1, because here an extra memory is not needed to perform this operation. So this is how we are looking for an element in a dictionary. Hi there. In this video, we will look at how to delete or remove an element from a dictionary. There are several ways of deleting an element from dictionary. The first method that we are going to look at here is pop method. So this method removes an item with the provided key and returns the value. Let's see how it works. So we have a dictionary over here. The pop method takes the key as a parameter. So we can provide any key from these pairs from here. So for example, if we want to delete this pair from here, we'll just need to put here name. So name is the key of this pair over here. And after running this, let's print out our dictionary to see that if it is deleted or not. So let's run our code. You see that this pair over here is removed. So in the new dictionary, we don't have this pair over here. And as we said before, this method returns the value of deleted pairs. So if we print out this expression over here, we will see that it's returning the value of AD over here. So if I run this code, you see that in the first print it returns AD, which means that it is returning the value of pair that is going to be deleted. This is useful in many cases in the applications. For example, sometimes in some applications you might need that before deleting any pair, you want to store this value somewhere. So in this case, this pop method is very useful. Now let's continue to the next method. The next method is pop item method. This method can be used to remove and return an arbitrary item from the dictionary, which means that here when we call this method, we will not put any parameter inside this. I'm not going to delete print from here because this method also returns some value. So if we call it in the same way, pop item, this method does not take any parameter. So let's run our code. I'll just clear here. You see that it's selecting randomly a pair and deleting it. In this case, it deleted education pairs, and as you see that it's returning the key and value. But in the case of pop method, it was returning only value, but in the pop item, it's returning key and value. So as you see that this pop item method removes any arbitrary pairs from the dictionary. Now the third method to delete elements from the dictionary is clear method. By using clear method, we can delete all pairs from this dictionary. So this is working also same way. We are calling it by using dictionary name and dot clear. If we call it, you will see that all elements from this dictionary is deleted. So as you see, now our dictionary is empty. So which means that by using clear method, we can delete all elements from the dictionary. Now finally, the last method to delete an element from the dictionary is del keyword. By using del keyword, we can delete any pair from the dictionary. And this is working differently. We are not calling it this way. We just need to call it straight away. Here we're writing, for example, del, then my dictionary. Then we need to specify the key. For example, if I want to delete this pair over here, I just need to put H here. This is the key for this pair over here. So if I run it now, print out our dictionary, you'll see that this pair over here is deleted. The pair with the H key is deleted. So by using del keyword, we can delete any pairs from the dictionary. And we can use del keyword to delete entire dictionary. In this case, we need to delete this code over here because after deleting it, we cannot print out. It will give us error. Let me just run it without deleting. You see that it gives that my dic is not defined, which means that it is deleted. So if I just comment this out and run it, you will see that everything is fine now. So by using del keyword, we can delete entire dictionary as well. So you might be interested what's time and space complexity for these operations over here. According to Python documentation, the time complexity for deleting an item is O1 time complexity in average case, but it is ON in the amortized worst case. So this is according to Python documentation, because in some cases deleting might take a long time. So that's why they called it amortized worst case. But the space complexity is O1 because here an additional memory is not required to perform this operation. We are just deleting the elements from the space. That's why the space complexity is O1. So this is all for this lecture. Hopefully everything is clear. And in this lecture, you have learned various ways of deleting an element from the dictionary. So let's continue to the next lecture, in which we will look at different methods of dictionary. Alright, in this lecture, we will look at dictionary methods in Python. You might be familiar with these methods from previous lectures. Here, I want to put everything together. The first method that we are going to look is clear method. We know from the previous lecture that this method deletes all elements from the dictionary. The syntax of this method is like this. The clear method does not take any parameter, and it does not return any value. It returns by default none. So let's see how this is working. As we shown, the syntax for clear method is we need to put dictionary name, then dot, and clear. After running this, let's print out our dictionary. And let's run our code. You see that this method clears all elements from the dictionary, and our dictionary is now empty. So this is one of built-in method of dictionary in Python. Now let's continue to the next method. The next method is copy method. This method returns a shallow copy of dictionary. It does not modify the original dictionary. When the method is called, a new dictionary is created, which is filled with copy of references from original dictionary. The syntax for copy method is like this. And copy method also does not take any parameter, and it returns a shallow copy of dictionary, and it does not modify the original one. So let's see how this is working. I'm going to clear this code from here, copy. Here I will create another dictionary based on this. And let's print both of them, the original one and the newly created one. So this is our new dictionary. Now if we run our code now, we will see that both dictionaries are same because this copy method creates the copy of this dictionary. So if we run our code, you see that both dictionaries are same, which means that by using copy method, we can copy a dictionary to a new dictionary and the original one will not change. Now let's continue to the next method. The next method is from keys method. The from keys method creates a new dictionary from given sequence of elements with value provided by user. The syntax of from keys method is like this. And here also, it is called by writing dot after the dictionary name. So the from keys method takes two parameters. First parameter is sequence. This is the sequence of elements which is to be used as keys from the new dictionary. And the second parameter is value. And this is optional parameter. The value which is set to each element of the dictionary. The from keys method returns a new dictionary with the given sequence of elements as the keys of dictionary. So let's see how this is working. As we said, it is returning new dictionary. So I'll create new dictionary here, new dict. Then I'll put something like this. This is empty dictionary and dot. First parameter is sequence, which will be as keys. I will put like this 1, 2, 3, and as value let's put 0. If I save this and print out this new dictionary from here, you will see that new dictionary is created with the keys of 1, 2, 3, and the values of all keys are same, which is 0. So let's run our code. You see that new dictionary is created. Here 1 is coming from here. This is key, and this one also key, and this one also key, which means that the elements from the sequence will be keys in the dictionary and the values will be the second parameter. If I leave this one empty without anything and run our code, you will see that the values will be none. You see the values by default assigned to none. And this is how from keys method works. Now let's continue to the next method. The next method is get method. The get method returns the value for specified key if the key is in the dictionary. The syntax of get method is like this. The get method takes maximum of 2 parameters. The first parameter is key, which is the key to be searched in the dictionary, and the second parameter is value, and this one is optional. This is the value to be returned if the key is not found. The default value for this second parameter is none. So the function returns the value for the specified key if the key is in the dictionary. But if the key is not in the dictionary and the value is not specified as a second parameter, then it will return none. And in the third case, if the key is not found in the dictionary and the value is specified, it will return the value which is specified in the second parameter. So let's see how this is working. If I put like this, my dictionary and get, here I'll provide key name. For example, let's put age. And for default value, let's put 27. If I just print out this, let me print out this like this. And let me delete this print statement from here. And let's run our code. You see that it returns the value of age key. over here. If I put something that does not exist inside this dictionary, it will return this value over here. For example, let's put city here. We know that we don't have city key in our dictionary, so if we run our code, it will return 27. This means that if the key does not exist in the dictionary, it will return the value that we specified here. If I delete this one and run our code, it will return none. This time you see that it returns none. And this is how get method is working in Python dictionary. So now let's continue to the next method. The next method is items method. The items method returns a view object that displays a list of dictionaries key-value tuple pairs. The syntax of items method is like this. The items method is similar to the dictionaries view item methods in Python 2.7. This method does not take any parameter, and it will return a view object that displays a list of given dictionaries key-value tuple pair. And let's see how this is working. Here one more time I will print out this and call my dictionary dot items. As we said, it's not taking any parameter. So let's run our code. Before running, let me clear out here. Okay, run. You see that it's returning a list of given dictionaries tuple pair. Here, this is one pair, and this is another pair, and this is another pair, and so on. So let's continue to the next method. The next method is keys method. The keys method returns a view object that displays the list of all keys in the dictionary. The syntax for keys method is like this. And this method does not take any parameter. It just returns a view object that displays a list of keys. When dictionary is changed, the view object also reflected this change. So let's see how this is working. Let me print out one more time this one. Dot keys and run it. You see that the first key over here is name and it puts here. The second key age, address and education, and we have all list of keys over here. And it's returning only the keys, not the values. So by using keys function, we can get all keys from given dictionary. Let's continue to the next method. The next method is popItem method. PopItem method returns and removes an arbitrary element from the dictionary. The syntax of popItem is like this. And it does not take any parameter. It returns an arbitrary element pair from the dictionary and removes that arbitrary element. In the lecture of how to remove element from the dictionary, we have discussed about this. So let's just see how this is working. I'm going to print out one more time my dictionary dot popItem. As we said, it does not take any parameter. That's why let's run it. It deleted these pairs from here and returned it. After this one, if we print out our dictionary, we see that that element is missing in our dictionary. So let me put like this and run our code. You see that these pairs is removed from the dictionary and it's not here, but it returns this pair, the one that it removed. Okay, let's continue to the next method. The next method is setDefault method. SetDefault method returns the value of key if key is in the dictionary. If not, it inserts key with a value to the dictionary. The syntax of setDefault is like this. SetDefault takes maximum of two parameters. The first parameter is key, which is the key to be searched in the dictionary, and the second parameter is default value, which will be used to insert in a dictionary. If the key does not exist in the dictionary, it will be inserted with default value. And this value is optional. If we haven't set it, it will be none. The return of this function is the value of key if it exists there. If the key is not exist in the dictionary and the default value is not specified, it will return none. And if the key is not exist in the dictionary and the default value is specified, it will return default value. Let's see how this is working. One more time, I will put dictionary here and call setDefault. As I said, it takes two parameters. The first parameter, let's put the key from the dictionary. Let's put the one which is exist. And the second parameter, I'll put, for example, added. So if I run this now, you see that it returns Eddie, which means that this is the value of name key over here. If I put, for example, name1 here and run it, and after that, let's print out our dictionary also, because new value will be added. So let's clear and run it. You see that it returns added, which means that this key does not exist in the dictionary, and this key with this value will be added in the dictionary. As you see, when we print out this element is here. So it's added into the dictionary. And this is how setDefault method is working in Python dictionaries. Let's continue to the next method. The next method is pop method. The pop method removes and returns an element from the dictionary having the given key. And we discussed about this method also. That's why I don't want to go in detail here. I just want to show you that the syntax of this method is like this, and it takes two parameters, key, which is to be searched for removal, and default value, which is to be returned when the key is not in the dictionary. So if I just run it, pop, for example, if I want to remove the one which does not exist, name 1, and here I will put a value not, the sample. If I run it now, you will see that it's returning not, which means that this key does not exist in this list and it cannot remove it. That's why it shows that not. By default, it returns none. So let's continue to the next function. The next function over here will be values function. The values method returns a view object that displays a list of values in the dictionary. You remember we discussed about keys method. In keys method, it was returning list of keys, but in this case, values method returns a list which contains values. The syntax of values method is like this. And values method does not take any parameter. It just returns a view object that displays a list of all values in the dictionary. Let's just print out this, my dictionary dot values. If we run our code, you see that it returns only values. So the first value is Eddie, the second value is 26, the third value is London, and fourth value is master. So by using values method, we can get all values from the dictionary. Now finally, the last method is update method. Let's see how it is working. The update method updates the dictionary with the elements from another dictionary object or from an iterable of key value pairs. The update method adds elements to the dictionary if the key is not in the dictionary. If the key is in the dictionary, it updates the key value with new value. The syntax of update is like this. The update method takes as a parameter another dictionary or an iterable object of key value pairs, generally tuples. Now you might not know what tuple is. In the next section we will talk about this, but here you just need to know that update method takes either a dictionary or a tuple as a parameter. If update method is called without passing parameters, the dictionary remains unchanged. The return from update method is none. So let's see how this is working. I will create another dictionary over here, new dic, and put some values in it. Here will be, for example, A1, B, B2, and C3. So if we call update method for this function dictionary over here, as a parameter, I will pass this one, new dictionary, and at the end, I will print out our dictionary over here. You will see that these elements from here updated to this dictionary. So let's run our code. Here you see that all elements from the second dictionary is updated to the first dictionary. So by using update method, we can take one dictionary and put it into another dictionary. This might be very useful when you do bulk update. And with this method, we are concluding this lecture. In this lecture, we have discussed different built-in methods in Python dictionaries. Hopefully, everything is clear. And by using these methods, we can make our codes much more easier. And hopefully, you understood everything very well. Now, in the next lecture, let's see dictionary operations. Hi there. Now, in the last video, we have learned about Python dictionary methods. Here, we will look at dictionary operations and built-in Python functions that can be used with dictionaries. The first operator that we are going to look at is in operator. We know from the list section that this operator determines whether an element exists in a collection or not. Here in dictionaries, in operator tells you whether something appears as a key in the dictionary or not. If that key exists in the dictionary, it returns true, otherwise it returns false. For example, in the example of dictionary from English to Spanish, we can check this. So let's check it. If I write something like this, one in my dictionary, and save and run our code, I need to print out this value over here, because otherwise we will not see the output. And run our code, you see that it returns true, because one key exists in our dictionary. If I write 2, 3, or 4, it will return true. But in the case of values, for example, if I write uno here from Spanish, you see that it returns false. So in operator only checks the keys. But if you want to use in operator for values, you remember we covered in the last lecture that we have values function which returns only values. So we can use here values and run our code. You see that in this case it returns true. So to check values, we need to call values function that we covered in the last lecture. The in operator uses different algorithm for lists and dictionaries. For lists, it uses a linear search algorithm. As the list gets longer, the search time gets longer in direction proportion to the length of list. For dictionaries, Python uses an algorithm called hash table that has a remarkable property. The in operator takes about the same amount of time no matter how many items there are in the dictionary. The time complexity for in operator in the dictionary is O1 because by taking a key, it calculates the index using a hash function and checks it in an associative array, and based on this, it returns true or false, which means that using in operator for checking any value in the dictionary is very efficient, and the time complexity for this operation is O1. Now the next statement that we are going to look in this lecture is for keyword. We have talked about this in the lecture of the traversing dictionary, so it's used for looping through any given collection, and it works for dictionary as well. Here, by using the for statement, we can visit each key of dictionary. So let's see how this is working. If I just delete this and write here for key in my dictionary, print key. Let's run our code. And before running, let me clear this. You see that it visits each pairs and print out the keys only. If you want to access value, you can just write here my dictionary name and inside brackets put the key. In this case, it will return the values. If you want to return both of them, you can put key here and with the comma you can put value and run our code. You see that in this case it returns pairs. So the first pair is this one and the second pair is this one and third pair is this one. So you might be interested what is the time complexity for operation in the dictionaries. It's ON time complexity, because in this case it has to visit all elements of the dictionary one by one. So this takes ON time complexity. Okay, now let's continue Python built-in functions that work with dictionaries. The first method here we are going to look at is all method. The all method returns true when all elements in the given iterable are true. If not, it returns false. The syntax of all method is like this. It takes any collection as parameter. In this case, it will be dictionary and return true or false. It returns true if all elements in an iterable are true. It returns false if all elements in the collection is false. So we have cases over here. Based on the case, the return value is changing. So if all values are true, it returns true. If all values are false, it returns false. If one value is true, it returns false. If one value is false, it returns again false. You can see it from this table. And if this is empty, it returns true. So let's see all these cases one by one, how this is working in practice. So the first case will be all values are true. Let me just delete this dictionary over here. I will create a new one in which we need to change the values true or false. So first case will be true and true. If I use all function now, you'll see that it returns true. So I need to print out this all. And as I said, all takes one parameter, which will be the collection. In our case, it's dictionary. So if I run our code, you see that it returns true. Even if I change these true values to the text, they are still true because we have some values over here. It will return true. You see that the values still here are true. So this was the first case in which all values are true. Okay, now let's look at the second case in which all values are false. So let's change our dictionary to all values all false. So I'll change values as well and the keys. Here I will put false. Here also I will put false. Now if I run our code now, you see that the result is false. So this is the second case in which all values are false. So let's continue to the third case. In third case, one value is true, others are false. So here if I put true and this value false, and let's create another pair over here, 2 is false. Now if I run our code, you see that in this case it returns false also. You see that it returns false. Now the fourth case is one value is false, the other is true. In this case also it returns false. And the fifth case is if we run it for empty dictionary, it will return true. So I'll just create here new dictionary as an empty dictionary and run it for this dictionary. Save it and run it. You see that in this case it returned true. So here we have learned that all method checks the elements in the given collection. So based on the values of element, it returns true or false. So let's continue to the next function. The next function is any function. Any method returns true if any element of collection is true. If not, any method will return false. So the syntax of any method is like this. Any method takes one parameter. The parameter might be list, string, or dictionary, which is a collection. And it returns true if at least one element of collection is true. And it returns false if all elements are false. or empty. So the difference between the any and all method is that in the case of any method, if you run it for empty collection, it returns false. But in case of all method, if you run it for empty collection, it returns true. And if one value in the collection is false, in the case of all method, it returns false. But if one value in the collection is true, in case of any method, it returns true. So let's see how this is working. One more time. If I run it for example, for this operation here, you see that one value is true. So it should return true in this case. Let's run it for this dictionary. Let's run our code. You see that it returns true. If one value in the dictionary is true, the value will be true. But if you run it for empty, in the case of all method, it returns true. But in case of any method, it returns false. So that's how any method works. Now let's continue to the next method. The next method is len method. The len function returns the number of items in the collection. The syntax of len method is like this. So it takes a sequence or a collection as a parameter. In this case, it will take dictionary. In case of dictionary, len method returns the number of pairs, not the number of all elements over here. It returns number of pairs. For example, if you run it for this dictionary, you will see that it returns 3. So let's run it. Because here in this dictionary, we have only 3 pairs. So len my dictionary. Let's close it. Let's run our code. You see that we have only 3 pairs over here. So let's continue to the next method. Now the next method is sorted method. Sorted function returns a sorted list from the items in an iterable. The sorted function sorts the elements of given collection in a specific order. The syntax of sorted function is like this. Sorted function take a maximum of 3 parameters. The first parameter is iterable. It might be any collection, list, tuple, string, or dictionary. In our case, it will be dictionary. Then the second parameter is reverse parameter. This is Boolean parameter. If true, the sorted list is reversed, but otherwise by default it's false. Then the third parameter is key parameter. This is a function that serves as a key for the sorted comparison. By default it's none. So let's see how this is working. Let's imagine that we have a dictionary like this. So if we want to sort this, we can call our sorted function. Let me delete this from here. Here I put sorted. And inside this one I'll put our dictionary. Let's run our code. So you see that it sorts the keys of this dictionary. If I put here reverse parameter as true, you see that the output will be different. So if I run our code, you see that in this case, it ordered the keys of dictionary, then reversed it. So this is the reverse version of the list over here. So let's see how key parameter works in sorted function. If you want your own implementation for sorting, the key parameter is very useful. Based on the results of the key function, you can sort given iterable. If I change, for example, these values over here, something different, let me just put different alphabets here. Here, let's put 5 character. So let me delete this here. If I put as a key parameter, for example, len, it will order these elements based off their length. So let's save and run our code. You see that the first one is length of 2, then the 3, then 4, then 5. It ordered them based on their length. Here, to make things clear, let me put the first parameter, for example, the length of 5 or 6, then rerun our code. You see that this value comes to at the end. So, which means that by using key parameter, we can put any function that we want here to order our dictionary. So with this function, we conclude our built-in Python functions for dictionary. So hopefully everything is clear. You have understood everything that I have explained here. Now in the next lecture, let's see what is the difference between dictionaries and lists. Hi there. Now in this lecture, we will look at what are the differences between dictionary and list. So let's get started. The first thing that we are going to look at here is dictionary is an ordered collection, but the list is ordered collection. So what does it mean? This means that when we declare a dictionary, the pairs in the dictionary will not be the same order as we declare. But in the case of list, they will be the same. The elements are stored in the memory as the way that we declared them. So let's continue to the next point. The next point is in dictionary, we access the values using their keys. But in case of list, we are accessing them using index. So if you know the keys, the dictionary is very efficient. The next point over here is in dictionary, we have key value pairs. But in the list, we have only elements. This means that for every element of dictionary, we have key and a value that assigned it. So as we mentioned here, we can access the values using their keys. So if in our data collection, we have unique key values, it's better to use dictionary. Because by using unique key values, we can access the dictionary very efficiently. But if we have ordered data, in this case, lists are very efficient. Because as I said before, lists are stored in memory the way that we declare them. So ordered data is very efficient with lists. So the last point is, in dictionary, we cannot duplicate members. We cannot have the same key for different values. But in list, duplicate elements are acceptable. Which means that, for example, in the list of integers, we can have 1 twice, 2 twice. So in this case, lists allow duplicate values. But in the case of dictionary, it's not allowed. So these are the points which reflect the differences between dictionary and list. Hopefully, you have understand all these points over here. So that's all for this lecture. Now, in the next lecture, let's see time and space complexity for dictionaries. Hi there. In this lecture, we will look at time and space complexity for Python dictionary. So let's get started. So the first operation here is creating a dictionary. The time complexity for creating a dictionary differs based on the length of dictionary, because when we create a dictionary, hash function has to calculate hash values for each element of the dictionary. So the time complexity depends on the length of dictionary. The space complexity is O(n), because it will take n number of elements in the memory. So let's continue to the next operation. Inserting a value in a dictionary is O(1) time complexity, but sometimes, again, based on the hash function calculation, it might take amortized O(n) time complexity. But this case happens rarely. That's why in most cases it's O(1) time complexity. So the space complexity for inserting a value in a dictionary is O(1). So next operation is traversing a dictionary. Traversing a dictionary is O(n) time complexity, because in this case we have to visit each and every element of dictionary one by one. So this operation is very time consuming. That's why it takes O(n) time complexity. So the space complexity is O(1), because when traversing a dictionary, an additional memory is not required. We are just visiting the element, we can print them or update them. So in this case, an additional space is not required. So accessing a given value in a dictionary is very efficient, because if we know the key, we can access any value in the dictionary. And this is very efficient because hash function can calculate an index of any element by using key. So this is very efficient in dictionaries for accessing a value. So this takes O(1) time complexity. In this case, the space complexity also O(1), because here again, an additional memory is not required. We are just accessing the value. So the next operation is searching a given value. Searching a given value, if we are searching linear search, then it is O(n) time complexity. But if we use in operator, then it becomes O(1) time complexity. Because once again here, by using key, a hash function can calculate index of the pairs. So straight away we can access the associative array and get the element from there. So if we are using in operator, time complexity is O(1). If we are using linear search, then the time complexity is O(n). The space complexity in this case O(1), because we are just searching for an element. So the next operation is deleting a given value. If we delete a given value from a dictionary, it's very efficient, because here again we need to access a value and delete it, which means that a hash function will calculate the index of this pair, and then we can access this element and delete straight away. That's why the time complexity is O(1). Here again the space complexity will be O(1), because here we're just deleting the element. So that's it for this lecture. So in this lecture we try to create a big picture of the time complexity of dictionary in Python. So hopefully you understood everything. Now with this lecture we have come to the end of this section, which is Python dictionary. Now with the next lecture we will start a brand new section, which is tuple. See you over there.